Down the stretch, down the stretch we go. And we're kind of into the easy, fun stuff. I think Tyler's on. Nice. Let's see. This is first. You guys see this? Did it pop up for you already?
I'm seeing your screen. There we go. Popped up.
This is a first. I haven't had this many hundreds at this point in the game. Um, Usually chasing people down eventually. Really well done though. Everybody's kind of staying with it. Um, I sent you two calendar invites. This week we're done it tomorrow. I mean, next Monday, we're going to do control 2 of 2. And then the following Monday, we're going to do the exam review. And then we're going to take a week off. So you guys can I'm going to break everybody into teams of 4. And I'm going to send you today an example of what the final presentations look like. They're meant to be fun, you know. I'm hoping that everybody kind of participates. Teams of 4, though. And the people on the left there, Jason Rose from Ulrich Steel. I already got Marcus is okay from PTA. I don't know if Meg's on or Marissa. Um, they haven't yet accepted the duties of group leader. But once they do, then I'm going to kind of just evenly distribute 4 for each team. And then we'll start the process and that will be like the second week of August when we have the final presentations. And then I'll usually invite your bosses and anybody else, some previous green belts that might want to come and sit in. I've already had asked people asking me, when's the final presentations? And yeah, so largely the presentation is you pick as a team, you just pick some data that you want to make talk and scream and figure out ways to make it talk and scream. So yeah, and then the exam, again, we'll do the review in 2 weeks. And then right away, I'll just email you the exam. It's done online through ClassMarker. And I would suggest that when you have your teams of 4, maybe schedule a Zoom meeting anyway, and just go through the exam together. Because I'm not a big exam person. Even when I was teaching college classes, I'm not a big, it's more important that you guys take a few tools away from this, that you might enjoy, might help you in the future. I'm not too worried about you cramming for an exam.
And
So, what's
that'll be
that?
the 27th, Bill.
Let's see, that would be the exam will
I mean,
be
I'm sorry, the 28th.
it'll be I think the exam oh yeah, the classes. I'm sorry, I'm confusing myself now, Bev. So next week we're gonna finish up the control part 2, and then the 28th we're gonna do the exam review. And of course, I'm gonna, because I know it's vacation season, stuff like that.
Yeah.
So I
Okay.
will record it, and send it to you. And I think and then right at the end of that class on the 28th, I give you a week or so to do it, to do the exam.
Okay.
And then and
Thank
you
you.
do it online and I get the grade and you get your certificate and a coffee mug. So it's all good. Good stuff. All right, so let's get into today's lesson. We'll start again, make it simple for everyone by doing this first. So we're talking about we're into the control phase. So the assumption is we have a process that we weren't really crazy about. And then we made some measurements and we measured a few vital factors, and then we analyzed that data, and then we made some improvements, and now we're into the control phase. And the control phase is essential, important, because once I get a process that is in control, now if I don't do anything to it, I think it's a second law of thermodynamics. Maybe somebody can help me, but it goes from control to chaos. All right. If you don't attend to it. So the control chart is a way to see if our process stays in control. Right. And you guys may be familiar with how they work. And we're going to build one right now on my weight. There's a little bit of homework. I'm going to take all the weight right now and do one. And if you just follow along, with the recording when you do it, just because again, for those of you who have done it in the past, I'm sorry for redundancy, but the two things that I need is the mean. I'm going to put that out right here on H1. Anybody want to help me on how to get how to do that? I want to get the average of all the weights.
You do equals
Yep,
um mean or average.
bingo.
Yeah.
Equals average. Click on it. Thank you, Nicola. Highlight the weight. There we go. And then standard deviation. Somebody besides Nicola? Don't jump at once.
I don't remember if it starts with the DEV or ST. Yeah.
Bingo. Standard deviation. Now we're going to take, I
Yeah.
got a P and an S. Which am I going to take?
This.
Yes.
Yes. Yeah.
Excellent. 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 Because that's a sample, right? Even though there's a lot of data, it's still a sample that I only do once a week. So there's my standard deviation. And what I'm going to need to build the chart is I got to fill in, I already did it ahead of time, what we call the mean, the upper control limit, and the lower control limit. And they're all going to be the same number, okay, for every single value. So we'll start with the mean, and it's going to be equals. And I'm going to just highlight the mean right there. And I'm going to put a little $ on each side just so it locks in. Dollar, dollar. Sorry for being slow. There it is. And then if I click on this little box down here, I get all of it. Bingo. So all my data has the average. And the upper control limit is going to be the average plus 3 standard deviations. Right? So to do that, I'm going to grab equals the average and the plus sign, parentheses, the number 3, and then asterisk 3 times the standard deviation, and close parentheses. And I'm going to put $ again to lock in. So it always grabs that H2. All right. $, $, enter. And there's my upper control limit. And then I'm going to do, for the lower control limit, I'm going to do exactly the same thing, except I'm going to subtract 3 standard deviations. So to do that, I'm going to get into this cell, little shortcut. So you don't have to do all that dollar signing and all that. Just take that plus, make it a minus. And my lower control limit is 169. So I'm going to go ahead and fill all these in and fill all these in. And that's all I really need to do the graph. So now I just highlight A, B, C, D, and E. I go to Insert, Recommended Charts. Oh, there she is. Beautiful. And there's my control chart or my weight from 2006 every week, 800 and something pieces of data. And I could change it to Billy's weight there to change it whatever I want. All right. So that's a control chart. And then the idea is that, on a weekly basis or daily or whatever the process calls for, whatever I needed to do, I would continue to add data. Right. And so I have this long control chart. Now, I think this is a really busy chart. So the homework's going to be just do a control chart for the years 2024 and 2025. Okay. So I don't want to just keep collecting data and putting it on a chart. I want to be able to tell me the most important thing for my process is when it tells me, stop, take a look, there's something wrong. In Lean, we call it and done, right? So and so the way to get to that, to understand when do I stop, we're going to review this in the PowerPoint, is we're going to go through what we call the Western Electric rules. All right. There's 8 of them. So I'm going to stop and not just keep measuring blindly. I'm going to stop my process when I find a data point that's outside the control limits. The upper control limit's in gray, and the lower control limit is in orange, and the line in the middle is the average. So we're going to need all those 3 in order to do these rules. But if I get one that's outside the control limit, then that tells me I have a special cause for variation or an outlier. All right. And again, back to the driving to work analogy. If it takes me half an hour to get to work, doesn't really mean every day is a half an hour. It might be 29 minutes, 31 minutes, 28 and a half minutes. If I track it every day, I mean, I might get lucky and once in a while it'll be on 30. But all those 28 to 29 to 31 to 32 minutes, those are all common causes of variation. Those are all part of the process, right? Those aren't things that I can easily Kaizen out of my process. But when I get a flat tire and it takes me an hour and a half, all of a sudden I'm going to have a line that's outside the control limit. Now that I can do something with. I could keep an eye on my tires, make sure they're inflated, sweep the garage, make sure there's no nails sticking up, that kind of stuff. All right. So that's the first thing is when I see something outside of my control limit. Now, in this case, this was 2006, 7 when I was fat. So that doesn't surprise me that I'm right at the top of the control limit there in the beginning, but there hasn't been anything since, as you can see. But let's say there was. Well, it could be it was a wedding or a Christmas party, or I went on vacation for 3 months and I ate every day like crazy, didn't exercise, anything. Like I have to be able to explain those special causes of variation in my process. Okay. I mean, you could put almost anything you want on this chart. You could put on-time delivery every day. You can put number of defects in the process every day. But it's a way to signal to me that something is, I need to take a closer look. All right. So the second rule is if I get 9, it's hard to see here because don't forget there's like 800 and something pieces of data in this chart, which is way too much, I think. I don't think I would make a chart for this much time, but I want just for teaching purposes. But if I get 9 data points on the same side of my average, then that's telling me something. Maybe I have a shift in my process a little bit. So I want to take a look at it. If I get 6 data points in a row that are either increasing or decreasing, I need to keep an eye on it. Okay, maybe I hired somebody new and and they're not testing it properly on the 3rd shift or something. Well, I might see, my scrap go up a little bit. You know what I mean? It's been nice and controlled, and all of a sudden I see 6 in a row steadily increasing. What happened? Is my machine breaking? Does it need maintenance? There's a million reasons. I lose power, but there's some special cause of variation for most of these things. If I get 14 in a row that are alternating up and down, all right, that indicates maybe I have a cycle happening, where I'm collecting the same data on all 3 shifts maybe, and they just test it differently, but it's going to be very consistent over the course of a month or 2 of measuring. We're going to start to see a cycle, right? 2 or 3 in a row, at least 2 deviations from the mean. So if I start to creep up towards my gray line and my orange line, and I start to see, 2 out of the last 2 or 3 pieces of data that got plotted and they're close to that second deviation line, and there's no line drawn here, but you understand what I'm saying, the mean, and then there's 3 standard deviations, then I want to take a look. If I have 4 and a 5 in a row that have at least 1 standard deviation from the center line on the same side of the line, I'm going to stop. If I get 15 in a row with 1 standard deviation on either side, I'm going to stop. I get 8 in a row. So these are all, and again, most of the time, guys, in real life, we're looking at, data points that are outside the control limit, probably 9 in a row on the same side, and then maybe some trends, 6 in a row, steadily increasing or decreasing. And if I do that, like if I just collect data and keep it in my computer, it doesn't do me any doesn't do me any good. And again, if it's almost like not even taking the data at all, right? If I'm just collecting data, pumping it into our computer system, it might as well stop. You know what I mean? Because there's nothing here. It's like, okay, what's going on? What's going on with our process? So, are there any questions here on the control chart? And so I think we're going to go into the PowerPoint now, and I'm going to show you today probably 3 or 4 different types of control charts. This is the one, the IR chart, that most times you're going to use. For our marketing friends on the call, the quality friends on the call, there's some charts that we're going to cover next week that because this is for data that we measure. There's also data that we count, discrete data, right? Which is, it could be number of people participating in a survey. It could be things that number of defects or defectives. Those are the things we count. Here we're measuring something, and this is the chart you're going to use most of the time, the IR chart. Okay. So the homework again will be to do exactly what I did, except let's forget everything up to 2023. We'll just do 2024 and 2025, see what that looks like. It should be thinner, you know what I mean, in terms of the upper and lower control limits. There should be a little bit more control around the mean since I smartened up. Right. Let's get into the PowerPoint. Down the stretch you go, people. Congrats. This is the easy part. And let's see. And here we go. I'm going to breeze through it because I think we covered what's most important. We're going to get into lean controls next week, which is going to be kind of cool. But we've defined the problem and the objectives. What do we need to improve? Can we figure that out? How do we measure it? After we've measured, can we analyze it? The data that we've measured? Can we recommend some identify implement improvements? And then now we're going to make sure that things don't go off the skids again due to inattention like my garden. The C in the DMAIC is about controlling the vital few variables that were identified in the analyze and improve phase. So today we're going to cover types of variation, we just did, special causes, and common causes. We're going to get into SPC data collection, control chart structure and rules, we just did. We're going to cover the IMR chart, which we just did without the MR, and I'll explain that in a second. We did the I chart. And we're going to cover the X bar R and the X bar S. And then next week, we're going to do a few more charts. And there's control plans on how to set up a control plan. And then a few lean controls. So lean is all throughout this certification in different parts of it. And there's no exception. So SPC. And again, I apologize for people that do this every day for a living. Might be a review for some. It's a statistical method to monitor process performance, right? And it helps us to distinguish between common causes of variation, which are inherent in the process, right? It's not like I'm going to get to work in 30 minutes every time. It's not like I'm going to get the same dimensions on a part every single time, okay? And then more importantly, this helps us when we see special cause of variation. Those are the ones where we want to make A3, right? Where we want to make an improvement on. The ones that are outliers, the ones that are special causes. And based on the Westinghouse rules, if I go 6 out in a row, above the mean, it also may signal to us a special cause of variation. So SPC, it presents the voice of the process, helps the process talk to us and communicate. A process is stable when there's no special causes. They've all been either, my tires are all checked. I got plenty of gasoline. I look ahead to see what traffic looks like, so I might take another way around. All those special causes of variation have been eliminated in the process of getting to work, for example. Same thing in my health data and my weight. The process is in statistical control. The future performance is predictable. That's what our goal is. right? As business owners, right, Tyler? That's all we think about. Tyler's a business owner over at Light
That's
Metals.
correct.
It's like we want to know that our processes are predictable and within certain limits. Um, the changes that we do see are random inherent variation, again, that we can Kaizen out, and there are not any trends, unnatural patterns, or outliers. It's such a powerful tool if you use it, if you look at it and you apply the rules. So common cause again is the random background noise. It's the 27, 28 minutes to get to work, 31, 32, 33 that I tell people I get there in half an hour, 30 minutes. Its presence in the process is expected and acceptable due to its relatively small influence. Special causes are signable cause variation is unnatural variation in the process. It's the cause of process instability and leads to defects of the products or crevices. I don't know if Nick's on from Marion, but they lost power on the sorter last week in the middle of the night, and it came in and there was a huge decrease in the amount of parts that got sorted. Well, that's definitely a special cause of variation. It's the signal of unanticipated change in the process, and it's possible to eliminate special causes. So it's caused by known factors, and sometimes we may not know what they are. We have to go through some root cause analysis. We got to go through the MAC to figure out what those factors are. But they're easier to identify, and they're opportunities. Common causes are things we have to live with pretty much. And they basically follow a normal distribution, which means they're predictable. So data collection, what's the measurement of interest? Is the data discrete, which means is it data that we count, like defects or defectives, like participation in a survey, stuff like that? Or is it something that we measure, which is continuous data? How many samples do we need? How often are we going to sample? Who's going to sample? Where are we going to sample? We have to have a robust, pretty good sampling strategy, right? Not just every once in a while. And do we use the raw data collected or transfer them to percentages, proportions, or rates? One of the things I'm a huge proponent of, obviously, is productivity in the form of sales per labor hour. How much do we ship today? How many hours does it take us to ship? And I think, that's a perfect example of a percentage that we can plot day to day and kind of come up with an upper and a lower exposure limit and track. So when sampling, we randomly select a group of items from the population of interest, and the subgroup size, in the case of my weight, is a counted as samples. So I did one per week. That's my subgroup size. Okay. I'm going to show you a couple of the control charts where maybe I'm weighing 10 times a day or 5 times a day. And I'm going to take all those 5 samples and put them on the board. All right, on my control chart. Rational subgrouping is the basic sampling scheme. The goal of rational subgrouping is to maximize the likelihood of detecting special cause variation. We want to make sure that we see special causes. We don't want to just go blow by them and then wonder. Number of orders per day, for my friends from Hubbard Hall, I call. Number of subgroups, subgroup size, and frequency have great impact on quality of control charts. The frequency depends on whether we have sufficient data to signal the changes in a process with reasonable time and cost. Sometimes I think we oversample, we over-collect data in some cases. Friday, weighing myself once a week. I suppose I could do it twice a day or 3 times a day or whatever. But I think I know that by Friday, I know what kind of week I had, and I know what special causes of variation might have caused what I'm looking at as I look into the scale. The more frequently, the higher cost we may trigger sometimes, because that's a lot of times we have to analyze our samples. And we often need the subject matter expert's knowledge on the nature and characteristics of the process. All right, here we go. So they present, analyze, and monitor performance. They detect special causes of variation, and they also help us determine whether the process is in statistical control, stable. And that's what you're going to be doing with the homework, right? Over the last 2 years with my weight data. I could throw in my blood pressure data, my pulse data, and you could do exactly the same thing and say, well, I'm not saying I'm healthy or I'm sick, but is the process in statistical control, by process of health, as measured by blood pressure, weight, and pulse. So here we go. Here's a run chart with a mean. This is the eye chart that we just did. The green is the mean. We have a vertical axis. In the case that we just did, it was the actual weight, and then time is on the x-axis. We have an upper control limit, and we're going to try to closely align those with plus or minus 3 sigma of the mean, which is 3 standard deviations. Now, this is a reminder, standard deviation is the average variation away from the mean from our data, right? It's like how far off are we? The tighter it is, the smaller that number. Hopefully when you see 2023 or 24, 25 data, it's much more in control. It's like a lot less sigma, a lot less standard deviation. And we have a lower control limit. It's going to be minus the 3 standard deviations, and a normal distribution curve would show the distribution of my data, because if you turn it sideways, then I could put that bell-shaped curve there with the mean, the green line right up the middle, and everything's falling inside that bell-shaped curve. So the Western Electric rules, we're looking for outliers, trends, cycling. Those are the types of things generally we're looking at. We're looking for 1 point outside the control limit or an outlier. Ding. We don't want it. We see it. We got to be able to explain it. Okay, we got to know what happened. On-time delivery is a perfect example. Well, we had one order that was, everything was on time except we had one order. Well, what's that one order? Could we put that on the A3 board, and say, all right, let's make sure that, whatever happened to make that one order late by a lot doesn't happen again. Test 2, 9 in a row on the same side of the center line, or maybe the process has shifted in the process. The process is temporarily shifted. The mean is shifted. Test 3, 6 points in a row, steadily increasing or decreasing. And this is a trend. It notifies, if we don't stop this, it could continue. Because again, the second law of thermodynamics is a process is going to go from control to chaos, unattended. That's 14 points in a row, up and down, alternating. It indicates a cycle. Again, we might see that if we're collecting data on off shifts, or if we're accumulating data from multiple, same process, different locations, things like that. Test 5, 2 to 3 points, or at least 2 standard deviations from the center line. So we're starting to creep up there, right? We're getting closer up. And a lot of times these upper and lower control limits are set by our customer. So all right, we're getting close. Let's take a look before we have a couple outliers on our hands and the wheels come off. 4 out of 5 points, at least 1 standard deviation from the center line on the same side. 15 in a row within 1 standard deviation from the center line on either side of the center line. It indicates a change in the level of variation around the mean. Again, we're looking like just pinpoint consistency with our processes. And test 8, 8 points in a row beyond 1 standard deviation from the center line on either side of it. While test 7 indicates narrowing of variation, test 8 indicates an increase in variation. So we want to see everything hovering sweet, nice, right around that center line, the mean, which I'm hoping you'll see with the last 2 years of weight. So if no data points fail, the process is in statistical control. If any data points fail any test for special causes, the process is unstable. So we got to set a periodic time frame for checking control limits and center lines. So when the process has just been developed, you got it running. Like in the case of my friends at Marion, you're going to check it more often. And when I know it's in control, I might check it once a week. I might check it every day. Until I know that it's where it's supposed to be. Manual construction of control charts. We kind of did it already, so we don't have to cover this, but you'll have it, when I give you guys the slides. Here's a selection chart for statistical process control. So the first decision always is on the top there is is my data continuous or attribute data, which is just another word for attribute, things we count, not continuous, things we measure. So today we're over into this right side here. And the first question we ask, and again, guys, 99% of the time, 90% of the time, you're going to be using the IMR chart, the first one. All right. But the first criteria is subgroup sample size. So if I have a subgroup of one weight per week, like my weight, then I'm going to go right to this individual and moving range chart. If I have 2 or 9 measurements at once that I want to chart, then I'm going to use an X bar R, which is a means and range chart. And if I have 10 plus weights that I have all at once, I weigh myself, take 10 of them, I'm going to plot that on a control chart. Then I'm going to use an X bar S, which is a means and standard deviation chart. On the other side, when we're getting to data that's discrete, attribute and discrete are the same thing. I don't know why these statisticians love to confuse people. But basically, we're looking at defects or defectives. Okay. And the defectives are a whole part that has to get thrown away. And one defective might have multiple defects, might have scratches, smudges, plus it's out of spec from a measurement standpoint. We're going to get into those next week. So the IMR, the one we just did, it plots an individual observation as a data point, my weight. The IMR chart, which is a separate chart, and we take these two and put them together, really, if you really want to get really technical and if you're really dealing with real fine, you want really fine degrees of accuracy, for when you get alerted, then you combine the I and MR. Most of the time, we're good with just having the I chart. But the MR chart is the difference between my weight last Friday, and the Friday before. So let's say it's 3 pounds. Well, I'm gonna chart that 3 pounds as a second control chart under the I chart, which I'm going to show you in a second. Technically, the I chart, which is the one we're doing for homework, is only valid if the MR chart is in control. So I'm getting the same range or close to the same range week to week in this case. It is the most sensitive of all charts to changes, and the underlying distribution is normal, as you saw with the sideways bell shape. So the I chart is what we did. There's a data point. We're taking the average. Let's see, center line is going to be the average. So you can see the sum of all my parts divided by the number of parts. That's the average. And the control limits, it's saying here go plus 2.66. We did plus 3 standard deviations times the average. And then the IMR chart, as I said before, it would be subtracting the 2 weights, whatever the difference in pounds I get, the range between those 2 measurements. I'm going to plot that separately. This is what it looks like. Again, 99.9% of the time, you're going to use this, what we just did for homework. Okay. That's going to give us enough information to make decisions. However, technically, if this chart is out of control, if there's a couple outliers there, then I'm not supposed to be able to depend 100% on the I chart on top. All right, don't worry about that. And the X bar R, same exact principle, except we're looking at sample sizes of 2 and 9 data points. So I'm going to weigh myself 9 times, 8 times, 7 times. I'm going to average those and I'm going to plot it. All right. The R chart below it is the difference between the highest and lowest values within that subgroup. So if I did 8 measurements, what's the highest and lowest values? Say it's 6 pounds and 3 pounds. Well, then 3 pounds would be what I chart. All right. And again, I don't think you need to do the R part. Here's the formulas for them. Pretty simple. This is the same as the one we just did on the R chart. We're just looking now at the range. We're plotting the range. And of the max and the min, from the measurements that we took. And same idea, we plot them together. The X bar S, same thing, except I have more than 9 samples. Now, instead of using the range, now I'm going to look at the standard deviation of those 10 or 12 or 15 measurements. and plot that below my X. There's the formulas in case you ever get bored and you want to see them. And same idea, except now I'm down the bottom here, I'm plotting the standard deviation of, not more than 9 data points. Again, this is going to be handy. We're going to get into it again next week, and we're going to pick up with the NP chart and then finish off the whole class next week. Man, congrats for getting this far. Any questions, guys? Do I have all right, Nick's on, good. Okay, good. Do I have Meg or Marissa on?
So I won't be here next Monday, just FYI.
No problem. I'll send you there's no homework next week. It's just more about we're gonna get through control next week, and I'm gonna start prepping you guys for the exam, and we're not gonna do the exam review until the following week, but so next week's no biggie.
If somebody backs out and you need another leader, let me know.
I knew that, Jody.
Okay.
Thank you.
Not a problem.
Have a great afternoon, people.
Thanks, Bill.
See you guys.
Thank you.
Thanks, Bill. See you.